Hi students, okay, now this is the last part of the kidneys. Pretty short, it's just dialysis machine. So dialysis machine comes in very handy when, let's say, a patient has some kidney insufficiency or kidney disease, or the patient is on life support and requires some additional support of removing toxins from the body. So kidney failure, it can be different forms. It can be chronic due to old age or due to long lifetime of eating rubbish food, etc. It can also be due to accidents. Okay, so when that happens, there will be a drastic drop in blood pressure. There can be diabetes and a whole issue of electrolyte imbalance, etc. So on and so forth. Now, a person can survive on only one kidney, which is why we can donate one kidney to a family member. But of course, if both the kidneys fail, or if that one surviving kidney fail, then osmoregulation as well as removal of toxins, excretion has to be controlled by exterior help, which is essentially the dialysis machine. Okay, so you can see over here, you have got the patient's arm at this region. Okay, so the patient's blood over here is being fed from a tube. So essentially, it will be a minor day surgery whereby they will have to insert a tubing, okay, or rather a little knob here for future insertion of the tubing or attachment of the tubing from the radial artery. So at each dialysis period, a tubing will be attached to this component or surgical part area of the radial artery, and the blood of the patient will then be pumped out into the dialysis machine, and when it is cleansed, it will flow back into the vein of the patient to be circulated around. So because of the machine size and also the patient's entire body system, it really depends how long and often dialysis is required, depending on the diet of the patient, the severity of the kidney disease, and also the age of the patient, and whether the patient has other issues such as heart problems. All right, so when it comes to the dialysis machine here, okay, the entire dialysis fluid here, you can see that it is all coiled up. Okay, so the coiling is very similar to our small intestines. Basically, the need for it is to increase the surface area to volume ratio so that your diffusion of substances can be extremely rapid. Okay, another thing, if you notice here, okay, so your blood of the patient is flowing in this direction, but the dialysis fluid is flowing in the opposite direction. So that will ensure that no matter at any point in time, there is maximum concentration gradient difference of the waste products. So if let's say there is only 5 units or 4 or even 1 unit of urea that is remaining in the patient's blood plasma, there will still be maximum concentration gradient difference because this fresh dialysis fluid has 0 waste products inside. Okay, so that will ensure that it has got a maximum amount of all the waste products that are being produced away from the blood plasma. Now, the coiled tube is also semi-permeable, so only small substances like glucose, amino acids, and urea will pass through. But of course, we do not want essential substances like glucose and amino acids to pass through. So what the dialysis fluid contains is that it will also have the exact same concentration that is required by the body system. Okay, so the dialysis fluid has all the essential substances to prevent these essential substances from the blood plasma to come out of the dialysis fluid into the blood plasma. Okay, but it does not have any waste products at all, and is going in the opposite direction to ensure that you have got maximum diffusion of all the waste products. Okay, so in this way, it can regulate the water potential. It can also remove the entire waste products from the patient. Okay, now that concludes this chapter on excretion and kidney for homeostasis. Thank you for watching.